Thank you, everyone. So we are starting the chapter 20, which is contain remote logging, TELNET, and the between SSH. So objective of this server to introduce the TELNET protocol and show how to implement local and remote logging, and the sub-option used in TELNET and how they are negotiated, define out of the band signaling in the TELNET, and to define different modes of operation in TELNET, to introduce SSH and the alternative to the telnet, and to show how to different components of SSH are combined to prove a secure connections over a insecure TCP connections, and to discuss port forwarding in the SSH and how it can be used to provide security for other applications. Chapter outline: Telnet and Secure Shell SSH. And Telnet is actually abbreviation of the terminal network, and it is standard TCP/IP protocol for virtual terminal services is proposed by ISO. Telnet enables the establishment of connection to remote system in a such way that is the local terminal appears to be the terminal at the remote systems. Topic discuss. This is the topic we are discussing: concept, time sharing environments, network virtualization terminal, embedding, options, sub-option negotiation, controlling the server, outbound signaling, escape character, modes of operation, user interface, and the security issue. So note, Telnet is a general purpose client server application program. So how to initiate a local logging systems. When a user logs into a local time sharing systems, it is called local logging. So as a user type, the terminal or a workstation running through a terminal emulator that keystrokes and accepted by the terminal driver. The terminal driver passes the characters into the operating systems, and the operating system in turn interrupts the combinations of the characters, and it evokes the desired application or program's utility. So this is how the local logging has been initiated. So how to make a remote logging? So when a user wants to access an application, program, or utility located on a remote machines, he or she perform remote logging. Here is the telnet client and the server programs comes into use. The user actually send the keystroke to the terminal driver when the local operating system accepted of the characters but does not interrupt them. The characters are sent to the telnet client, which transform the characters to universal character are so-called network virtual terminal NVT characters delivered to the local TCP/IP stack through the internet. Concept of VVT, how to VVT concept is executed. So the telnet solves the problem by defining a universal interface called is network virtual terminal NVT character set. So via this interface, the client telnet translate characters or data commands that come from the local network into a NVT form and deliver them to the network. The server telnet, on the other hand, translate the data and command from the NVT from into the both acceptable by remote operators or remote computers. Format of data characters: there are two formats. One is data character format and another one is control character format. So NVT uses the two set of characters, data and control. Both are contain 8 bytes. So this is the some NVT control characteristics to send control character between computers from the client or server. NVT uses the 8-bit character set in which is the highest order bit is set to 1, and this figure shows the sum of the control characters and their meanings. Later we will categorize those control characters on the basis of their functionalities. Example of the embedding, how to make an embedding. However, in the difficult implication of the telnet, the user cannot edit actually locally. The editing is done at the remote server, and the backspace character or translation into two remote characters AC and EC, which is embedded in the data and sent to the remote server. Actually, what we send to the remote server shown in these figures, client and the remote server house. So this is the example of a embedding. Options. Telnet lets the client and the server negotiate options before dying or use the user services. Options are extra feature by available with the user with more sophisticated terminals. User with simpler terminals can use default features. Some control characters discussed previously are used to define options. This table shows the some common options: binary, echo, surpass, go ahead, status, timing mark, terminal check, terminal speed, line mode. So this is the NVT character set for option negotiation. Character is defining here: will, won't, do or don't. So meaning offering to enable, will, won't, rejecting to enable, do, approval to enable, don't, disapproving to the enable. So we will show some example in the upcoming slide. So offer to enable and options. As we seen earlier, a party can offer for enabling an option if it is right to do so. So there is an offer, can be approval or disapproval by the other party, the will sender. So the offering party send the will command, which means will I enable options. The other party receiver send the do command or do not command, which means please do, or the don't command, which means please don't. And request for enable and options, this is the same thing we seen in the previous slide. User request for do options to enable options to the receiver, and receiver send the response will or won't. So if he sends the will options, it means I will, and the won't option confirms, which meant I won't. Offer to disable an options. So this is the same options. A party can offer for disable an options, and the other party must approve or offering. It cannot be disapproved. The offering party send the own command, which means I won't use my owns these options anymore, and the answer must be don't command, which means don't use it anymore, don't use it. Request to disable an options, same as party can request initiate and request to the another party for disabling an options, and the other party must accept the request. It cannot be rejected. The requesting party send the don't commands. Requesting party send the don't commands, which means please don't use it the option anymore, and the answer must be shown in the own command. It means I won't use it anymore. This is an example, shows an option negotiation. In this example, the client wants to server to echo each character sent to the server. In the other words, when a character is typed at the user keyboard terminal, it goes to the server and it's sent back to the screen of the user before being processed. The echo option is enabled by the server because it is the server that sends the character back to the user terminal. Therefore, The client should request from the server the enabling an option using the do. The request consists three characters: ISC, do, and echo. The server accepts the request to enable the options. It confirms the client by sending three characters approval: ISC, will, and echo. The example of echo option: do enable the echo option requested by the client, do, and the echo option response by the server is will. I will enable the options. In this example, client actually wants the server in echo each character to the server. In the other words, when a character is typed at the user keyboard terminus, it goes to the server and it's sent back to a screen of the user being processed. So the echo option is enabled by the server because it is the sends characters back to the user terminal. Therefore, the client should request from the server is enabling the options using do. The request consists of three characters: ISC, do, and the echo. ISC, do, and the echo. The server accepts the request for enable options. It informs the client by sending three characters approval: ISC, will, and echo. Example for sub-option negotiation. Some control characters actually can be used in the control of the remote server. When an application program is running on the local computer, special characters are used to interrupt this program. For example, or is the last character type, for example, or deleted key or backspace key, and so on. However, a program is running on a remote control computer, those characters actually sent by the remote machine, which is transferring between client and the server. Here is the character used to control a program running on a remote servers. Character is IP, AO, AOIT, EC, and EL. So there is the decimal and the binary code is given here. Meaning is IP interrupt processes, AO is abort output, AOIT is are you there, EC is erase the last character, and EL is erase line. Example of interrupting and application program. This figure shows how to interrupt a runway application. Actually, runway application program at the server side. This user type, when the user type Control C in the keyboard, but the telnet client sends the combination of ISC and the IP to the server. Control C, telnet client IP, and ASC options sent to the telnet server and the application program. And the next is outbound signaling. Outbound signal is also transferring between the telnet server process who wants to send the outbound sequence character to the either processes. It embeds the sequence in the data stream and insert a special character called GM data mark. However, it is informed to the other party. It creates a TCP segment with an urgent bit set, and urgent pointer to the urgent pointing to the DM character. And when it is receiving processes to the data, it reads the data and discards the data pretending to the control character ISC. And for IP, for example, so when it reads to the DM characters, it remaining data is handled normally, and in the other words, the DM character is used in the synchronization characters that shows in the receiving processes from the urgent mode in the normal mode. In this way, actually control character IP is delivered is out of band of the operating system, which is the appropriate functions to the interrupt of running application program. Two different interruption. A character type is user is normally sent to a server. However, sometimes the user wants to characters interrupt by the clients instead of the server. In this case, the user can be the escape character, normally control plus when it is shown, control plus, and this compare of the interruption of the application program at the remote site of the interaction of the line for the interruption of the client, interruption of the application program. In this example, we used to default a mode to show the concept and the differentiations, even though it is the almost absolute today. The client and the server negotiate the terminal type and the terminal speed, and then the server check the login and login password of the user. In this example, we'll use to the default mode to show the concept of the differentiation even through the almost absolute. This option is almost absolute today. The client server is negotiating the terminal type, and the server checks the login and password options in the user. So in this example, we'll show how the client switches the character mode, thus request shop the client request to the server, enable to superpass go ahead and echo option to see the figure 116. So this is the go ahead processes. Client server requested for go ahead from the client and do surprise go ahead, and we will show how to the client switches the character mode. This required that be the client request to the server to enable the surprise go ahead and the echo option, do echo, will echo options. In this options, login and password and the binary code is here. Example of interfacing command. So command is option open, close, display and mode, meaning connect to a remote computer, close the connections, display show the operating parameters, and mode is changed to line or character mode. So command is also set, status, send and quit, meaning is set to the operating parameters, display the status information, send special characters, quit, exit telnet. Secure Shell SSH. Another popular remote login application is Secure Shell. SSH like Telnet uses TCP at the underlying transport protocol, but SSH is more secured and provides more services than the Telnet. So we discussed in this topic is version, components, port forwarding, format of the SSH packets. Component of SSH. So another popular remote login application is Secure Shell SSH like Telnet uses the TCP underlying transport protocol layer, but SSH is more secure that provides more services than the Telnet. So SSH is actually proposed application layer protocol with 4 components, which is SSH application, authentication, connection and the transformations. Port forwarding is kind of one of the interesting services provided by the SSH protocol, is to provide port forwarding. So we can use the secure channel available in the SSH to access an application program that does not provide secure services. Applications such as Telnet and the SMTP can use the services of the SSH using port forwarding mechanism. SSH port forwarding mechanism create a tunnel through which means belonging to the other protocol that can travel. For this reason, this mechanism is sometimes referred to SSH tunneling. Actually, this figure shows the concept of port forwarding. And the last one is SSH packet format. So packet format is actually there are brief description in this field. So there are different type of length, actually 4 byte length, actually 4 byte of the packet including type, and the padding is actually 1 to 8 byte it contain, or padding is added in the packet format and make it the attack on the security professional more difficult. Another is type is actually 1 bit format, and the data is the different kind of variable formatted with length and data can be found by, and the CHC is last one is 4 byte. So this is the end of chapter 20. So we'll go into the 21 now. So this is chapter 21. So this chapter contains file transfer, FTP and TFTP. So objective of this server is to discuss the FTP and two connections used in protocol, control connection and the data connection, to discuss 6 class commands, explain 3 type of file transferred by FTP, to show some user-friendly commands used by some FTP interface, to discuss any one FTP in this application, and to discuss how file transfer can be done using a secure channel. And the last one is to discuss TFTP as a simple file transfer protocol without the complexities and the sophistications of FTP. And the objectives continue to discuss 5 types of TFTP message and their applications, to discuss the scorer appearance, bug related TCP/TP and flow related control, and the DSTP to the initializing device by downloading and configuring files. So FTP contains file transfer protocol is the standard mechanism provided by TCP/IP for copying a file from one host to another. All the transferring files from one system to another system simple and straightforward, and the two systems may have different directory structure. All of those problems have been solved by FTP in a very simple and elegant approach. Topic discussed in these sections: connections, communications, command processing, file transfer, autonomous FTP, security for FTP, and the SFTP program. And here is a note: FTP uses the services of TCP. It needs 2 TCP connection. The well-known port 21 is used for the control connection, and the well-known port 20 for the data connection. So the FTP, how the FTP processes has been continued or processes has been executed. This graph shows the basic model of FTP. Actually, the client has 3 components: user interface, client control process, and the client data transfer processes. So the server has 2 components, and the server control process and the server data process. So the control connection is made between control processes. The data connection is made between the data transfer processes. Actually, the control connection remain connected during the entire interactive FTP sessions. The data connection is opened and then closed for each file transferred. It opens each time command that involve transferring file and are used. So the FTP session, the control connection is when open. While the control connection is open, the data connection can be opened and closed multiple times if several files are transferred between the user and the server. So opening in the control connection. So control connection is created in the same way as the other application program described so far. There are 2 steps. One is the server issues in the passive open on the well-known port 21 and the waits for client, and 2 is the client uses in the ephemeral port issues in the active open, and the connection remains open during the entire processes. The service type used by ITP protocol and the minimized delay, because this is an interactive connection between a user, human, and the server. The user types commands and accepts to receive response without significant delay. This figure shows the initial connections between the server and the client. First one is passive open by server, and the second one is later active open by client. So creating the data connection, how to create a data connection. The data connection is actually uses the well-known port 20 at the server side. However, the creation of data connection is different from what we have seen so far. The following shows how FTP creates the data connection. The client is not the server, issues the passive open using the ephemeral port. The must done by the client because it is client is issued by command for transferring files. The client sends the port number to server using the port command AOL and the discuss command shortly. And the second time, data processes and the active open processes port number and the issue an active open using the well-known port 20 and the receive ephemeral port number. using control connection. So FTP uses the same approach as Telnet or SMTP to communicate across the control connection. It uses the NVT SCC11 character to set these processes. Communication is achieved through the commands and the responses. The simple method is adequate for the control connection because we send one commands at a time. So using the data connection, the purpose and the implement of the data connection is different from that one of the control connection. We want to transfer file through the data connection. Actually, the client must be defined by the type of file to be transferred or the structure of the data and the transmission mode. Before sending the file through the data connection, we prepare for transmission through the control connection. The problem is resolved by the defining three attributes of communication: file type, data structure, and the transmission mode. Command processing is FTP use the control connection to establish a communication between the client control process and the server control process. During this communication, the command are sent from the client to the server and the response are sent from the server to the client. So this commands is actually let the user across to the remote system. Access command, how to access command, user id, description, user information, password, user password, account to be changed, account information, reinitialized, log out of the system, for the previous command. Here is a sample of file management commands, how to management your file. Those command is let the user access to the file system on the remote computer. They allow to the user to navigate through the directory structure, create new direction, delete file, and so on. Data formatting commands, how to format your data. Those commands actually let the user define the data structure, file type, and transmission mode. The define format is then used by file transfer command: type, structure, and the mode. So description type is defined file type, structure is defined organization of the data, and the mode is defined transmission mode. Port defining commands. Those commands actually defining the port number for the data connection for the client side. There are two methods to do this. One is first method using the port command. The client can use the applica port number and send it to the server using a passive open. File transfer command. Those commands actually let the user file transfer, retrieve, sort, appliance, stou, awlo, rest, and stuff. So here is the description of all the commands: retrieve file, store file, similar to store, same to store, allocate storage space, position file market, and the specific data points, return status of the file. Miscellaneous command. Those commands is deliver information to the FTP user actually at the client side. So when you deliver the information at the FTP user client side, this command will require for deliver your information. So here is some response code. So the third digit provide additional information. This code actually shows a brief list of possible responses using all three digits. So here is the description code number, and the description is given here for the responses code. And the responses code also continue. There's the code number and the description is as well. So how to file transfer? This graph shows the file transfer process. File transfer actually occur over the data connection under the control command send over the control connection. So however, we should remember the file transfer in FTP means one of three things, which is here: storing a file, retrieving a file, and retrieving list. So a file has to be copied from the server to the client download. This is called retrieving file. It is done under the supervision of the retrieve command. A file to be copied to the client server upload. This is called storing a file, and it is done under the supervision of the store command. So this figure shows an example of using FTP for retrieving a list of items in directory. So example of a directory connection for retrieving a list of items in the directory. So client, and here is the server. Control connection, server ready. So user, he is giving his username and he is giving his password, user logging, port number, data connection open. This figure shows an example of using the FTP for retrieving the list of items from the directory. A list of directory of file name to be sent from the server to the client, and this is done under the supervision of list command. Note that FTP treats a list of directory of file names of a file, so it is sent over the data connection always. This is the data connection, and the file directory has been transferred from the data process and the data process client and the server side. So here is the coding example. We will be going to skip this file. The download FTP, password, login successful, entering passive mode, data file retrieve, directory send OK, quit, and send the goodbye. This figure shows the actual FTP session that parallels in the examples. So the next figure shows an example how to image a binary file in storage. How to image file is stored. How to image file is stored. So the same thing, kind of the previous data transfer. After the control connection, port is created 21. So this port, when is created, the FTP server sends the services response on the control connections, and the client sent user command and then the password command, and the server response is 230 user logging OK. So this is how the data connection opened shortly. Then there is the file type. The image file type is requested from the client side, and the server side, this is the OK, and the data transfer processing has been completed, and then the quiet request has been initiated and the server closing. So same as the data, record a file, transfer between the data connection. So the example of autonomous FTP, we assume that some public data are available on the internet. Here is the graph, and the binary code is given here. We cannot read the binary number. So the TFTP, there are always occasions when we need to simplify a copy file without need for all the features of the FTP protocol. For example, when a Dixlex workstation or router is booted, we need to download the bootstrap and the configurations file. Here we do not need all the sophistication provided in the FTP. We just need a protocol that quickly copy the file. So this sections we will be discussing message, connection, data transfer, UDP ports, TFTP example, TFTP options, security, and the applications. TFTP user of the services of the UDP on the well-known port is 69. Message categories, there are 5 types of TFTP messages: request, WRK, data, SCK, and the error, which is shown in this graph. Request formatted, the read request formatted is used by the client to establish a connection for retrieving data from the server. So this is the format how to retrieve a data from the server. WRQ format, the written request format, which is messaged used by the client to establish a connection for writing the data, file name, variable, writing the data to the server. The format is the same as RRQ as we seen in the previous slide, except that the option code 2 is changed here. This is the option code 2, In the previous slide it was the option code 1. So this is the difference. So data format is message used by the client or the server to send blocks of the data. This format shows the data messages field are as follows: the opcode, the first field of 2 bytes of operations code, and the value is 3 for data messages. 2 bytes for operation code and 2 bytes for option code for data messages. And ACK format, the acknowledgement message is used by the client server to acknowledge the receipt or data book. The message is only 4 bytes long. So option code 4 bytes long and the block number 2 byte and 2 byte. And the error format, the error message is actually used by the client or the server when a connection cannot be established or when there is a problem during data transmission. It can be sent as a negative response to the RRQ or the WRQ. It can also be used in the next block, cannot be transferred during the actual data transfer phases. The error message is not used to declare a damage or duplicate messages. Those problems are resolved by error control mechanism discussed later in chapter in the format of error message is shown. So error message code option code is 5, error number 2 bytes and 2 bytes in the same, error data variable and all 0 byte is 1 byte. So error number and their meaning, 0 number and their meaning is not defined, 1 file not defined, access violation for 2, disk full for 3, illegal operation for 4, and unknown port number is 5, file already exists is 6, and the 7 is no such users. And the connection establishment between the client and the server. So the establishment connection for reading, the TFTP client send the RRQ request. This is the RRQ request to the message. The name of the file and the transmission mode is defined in the message. If the server can transfer a file, it responds positively with the data messages containing the first block of the data. So if there is a problem such as difficulty is opening a file or permission restricted, the server responds negatively by sending an error message. So this is the error message. To writing, established a connection for writing, the FTP WRQ writing request, the FTP client user and the WR messages, the name of the file and the transmission mode is defined for the messages. If the server can accept a copy of the file, it responds positively with an ACK message using a value of 0 and the block number. So is there any problem? The server responds negatively by sending a error message. Same as for reading and same as for writing. And the server appearance bug. So this is a kind of error control mechanism. All flow and error control mechanisms symmetric in TFTP. It can be lead to a problem known as the scorer appearance bug, named for the cartoon character who invariably conjures up a mob of continuously repeats itself. This will happen if the ACC message of the packet is not lost by delete. In this situation, every succeeding block is sent twice and every succeeding acknowledgement is received twice. So this figure shows the situation. The acknowledgement for fifth block is delayed here, and after the timeout expiration the sender retransferred the fifth block and will by the acknowledgement and the receiver again. So the sender received 2 acknowledgement for the fifth block, which triggered it sends to the 6th 9th block. So the receiver actually received the 6 blocks twice and sent 2 acknowledgement in result in the number 7. UDP port number used by TFTP. So when a process actually uses the services of UDP, the server process issue a passive open of the well-known port and wait for the client processes to issue an active open for epidemical port. After the connection is established, the client and the server communicate using those ports. TFTP follow a different set of steps because the communication between a client and the TFTP and the server TFTP can be quite lengthy here. Active open, if a TFTP server uses the well-known port is 69 and the communication with a single client, no other clients can be use those services during the time. So the solution is the problem is shows here is to use a well-known port, the initial connection, and the epidemical port for remaining communications. TFTP example. This figure shows an example for a TFTP transmission processes. The client wants to retrieve a copy of contents of each one byte file copied, and the client sends to RRQ messages. The server sent the first block is credited the first 512 bytes, which is receive and interact and acknowledgement. Those are two messages in the connection establishment. The second block carrying in the first 512 bytes is lost, and after the timeout the server retransmission is the block when the receive. The third block is carrying the third 512 1 byte and the receive the intake, but the acknowledgement is lost after the timeout. The receiver transmit the acknowledgement. The last block is actually carrying the remaining 464 bytes, carrying the remaining 464 bytes and receiving the damage. So the client is simply discards it, and after the timeout the server transmit the block. This message is considered the connection termination because the block carries a fewer than 512 bytes. So uses of the TFTP and DCPTP. So orchestration and the server, DCDP client and the DCDP server, and the connection between TFTP client and the TFTP server. So this is an extension to the TFTP protocol that allows to appearing into the options, and the RRQ of WRQ messages has been postponed. Those options are mainly used to negotiate the size of the block and possibly the initial sequence number. Without the options of the size of a block is 512 bytes is except for the last block actually. So the negotiation can be defined between client and the server is so long as the messages can be encapsulated in a UDP user diagram. So this is the last slide of 21 chapter. Thank you so much for watching this.